In this short video, I'm going to introduce you to HY-8 software for culvert hydraulic design. We're going to go through a real example. You're going to do an existing condition, analyze the existing conditions of a culvert, and then tweak that to find a proposed condition for that culvert. In the description section of this video, there's a link to a GitHub page that you can see some documents that have been prepared for you, related to culvert hydraulic design and the problem that we are trying to solve right now. And the information, the survey data has been also presented to you in addition to cross-sectional data that I'm going to use in this video. So highly recommend checking out the link in the description section. And also this video should be linked in that webpage as well. All right, so um, you can download HY-8 from a Federal Highway Administration website. And again, the link to download this software is also in the description section as well. Once you open HY-8, we are going to add a new culvert crossing. So we're going to keep this and then continue. All right. The first thing that we want to do, we want to add a crossing. Instead of calling it crossing 1, I am going to call it existing condition. Perfect. Now we need to enter the data that we have. The data is usually provided to you through hydrologic modeling that will give you the discharge data and also the survey data that will give you the invert elevations, that will give you the tailwater condition, the tailwater channel, so on and so forth. All right, so the first thing that we want to do is putting the discharge data in. There are different ways of doing this. You can select the reoccurrence, and then when you click define, you will see that you have the option to enter flow for different um, annual exceedance probabilities or reoccurrence intervals. This is one option that you have. The other option would be user-defined values. You can define some values, any number of values that you want to. And the other option that I'm going to use is the design flow, minimum flow, and maximum flow. Okay, so in that web page, the GitHub page, I have listed the design flows. The design flow that I'm going to use is going to be for a 50-year flow, which has the annual exceedance probability of 2%. So it's going to be 243.76 CFS. That's the design flow. The minimum flow, I want to have 184.31, and the maximum flow of 312.38. All right. Next, we are going to define the tailwater data. If any of these sound unfamiliar to you, um, that document that I put together, it has a terminology section that you can take a look at and understand different components of a culvert. The tailwater data is essentially the channel that is in the downstream of your culvert. You have different options similar to discharge data. You can have a rectangular, trapezoidal, triangular, or you can either enter your rating curve if you have that data. I'm going to use irregular channel because I have had the survey team giving me a cross section right after the culvert, and that cross section has been saved in an Excel sheet that I'm going to show you in a second. So this is the cross section that we have. The first column is station, the second column is elevation, and the third column is manning roughness. How do I know that should be the format? So when you choose irregular channel and go to define, you can see that this is exactly how I have sorted those data: station, elevation, and Manning's roughness. First thing that we need to have is the slope of channel. So the slope of channel, based on the survey data, we know that it's going to be 1% or 0.01. And the number of cross sections is essentially the number of rows that your Excel sheet has. We have 311 rows. And while I'm here, I'm going to select these three columns like this and use Control C or right click on it and copy it. Okay, so 311 if you remember, and then selecting these three columns and Control V or paste the data over here, 311. You can plot it to see how the cross section right after the culvert looks like. This is the surveyed cross section for the tailwater channel. Okay, so I'm going to close this and hit OK. Perfect. Now, we need to have some information about the roadway data. The first thing is roadway station, the first roadway station. Normally this should be 0 unless you have different value based on the as-built or based on the survey that you got. The crest length is essentially, so if you're looking at your culvert front, the if you measure the top of the culvert, that would be your crest length, the top of a culvert that water can overflow and overtop the road. Okay, that would be the crest length. This number is only important if the road overflows. If the road doesn't overflow, it doesn't matter. This number won't be used in any of the equations that HY-8 uses. So based on the survey data that you have access to in the GitHub link as well, this number is 90 feet. Crest elevation is the elevation of the top of the road, and we have that information to be 1020, 1025.16. Roadway is paved. You have other options as well to choose from, but the roadway that we are designing is paved, and the top width has been surveyed, and the value is 134.58. Okay, so this is all of the information related to roadway. Now we're going to move to the culvert information. So you can choose a name for the culvert. You can obviously change this culvert to culvert since we only going to have one barrel. Um, it is a circular culvert. It is concrete, so these are all selected. And once concrete is selected, the Manning's roughness is automatically selected for it as well. Based on some survey data, we know that the culvert has the diameter of 2.5 feet. The embedded depth is if the bottom of the culvert is embedded within the channel. In our case, it is not, so this is going to be 0. This is a straight culvert, it's a cross culvert, and we know that the configuration of the inlets is square edge with head wall. This K sub E determines your um, uh, the head loss that you're going to experience when the water gets into the culvert. Okay, and there is no inlet depression. The inlet depression is essentially a small pond that some of the culverts have. So when water will be collected in that small pond first, and then goes through the barrel of the culvert. All right. And last but not least, we need to input the site data. We need the inlet station. The inlet station is 0, and the outlet station would be the length of your pipe because this was 0. So the length of the pipe of this culvert is 163.751 feet. Inlet elevation that I jumped over is going to be 1019.69, and then outlet elevation is going to be 1019.46. Perfect. And then the slope should be automatically calculated for you. And we have only one barrel, one circular concrete pipe. All right, so we have imported all of that information. I'm going to move this over here so you can see this page. When I click OK, you can see a culvert appears under the existing condition. And then if you double click on it, after a couple of seconds, you will be able to see a graphical representation of our existing culvert. The reason that it's thinking is because the equations that are used to solve the headwater and tailwater, these are solved numerically, so it's going to have some iterations. All right, and now if I again move this, you can see that this is our culvert, headwater, tailwater, the bottom of the channel, the tailwater. This is the black line is the barrel. The blue line is the water in the barrel in the pipe, and the red dashed line is your critical depth. If you close this and right click on the graph, you can go under legends and put the legend on top to see a legend for the data that you got over here. Okay, so now that we have this, and you can see that this, obviously our road is, which is the brown line over here, is overtopped, and this is for our design discharge. But we want to see this analysis a little bit closer. So if you right click on your culvert and click on Analyze Crossing, you will see a summary table that gives you the headwater elevation for total discharges, what goes through the culvert, and what goes over the road. Okay, now what good information this is going to give us? The best one is going to be the last row over here. It tells you what is the flow that the culvert carries, and what is the flow that goes, actually, what is the flow that culvert can carry without overtopping. And anything after this, the culvert is going to overtop. As you can see over here, there's a roadway discharge. All of these have value. Remember that this 243, this was our design discharge. And for this design discharge, the culvert carries only 47 CFS, and the rest of flow goes over the road. Okay, so that's good information to have. Now let's click culvert summary table right over here. This gives a lot of good information to us as well. The first thing that I want to highlight is the inlet control versus outlet control. As you can see, HY-8 calculates both inlet control depth and outlet control depth, and um, um, it gives you the highest one, which is in this case outlet control, and you can see the numbers are bold. This is telling me that this culvert is outlet controlled because these numbers are bold and also they are higher than inlet control depth. Another good information that it gives you is going to be the outlet velocity. These velocities are very high as expected because we have a very small pipe and we have a lot of headwater behind that pipe. Okay, this is very good information to have. If you're interested to know the flow type like 7M2C, if you want to understand what this is, you can click on the flow types over here and then find 7M2 and C. So we are right over here. Outlet control, and it's going to be the outlet depth is going to be critical. Is that correct? Yes, it is, because look at the blue line. The blue line is approaching the red dashed line, which is our critical depth. Okay, very good information. This is a lot of good information that HY-8 prints for you. Okay, so I'm going to close this. Um, so this is how headwater looks like for our existing condition. Now what we want to do in the proposed condition is to modify this culvert, maybe add some barrels, change the slope, so on and so forth, to make sure that the depth over here is below the top of the road, so it's not overtopping. Different states that have different guidelines related to the freeboard, which means the distance from the top of the road to the allowable headwater. Some states have 1 foot, 1.5. So I highly recommend look at your state's drainage manual to understand the cover requirement and also to understand the freeboard requirements for specific pipes and the jurisdiction that you are in. All right, before moving with the proposed conditions, I'm going to save this project on my desktop and I'm going to call it HY-8 demo and click save. All right, this is the file that it generates. I'm going to save it again. And if you're interested what this file has in it, you can always open it with a text editor to see what is stored in it. You can see the units, whatever we entered over there is essentially now entered as a text format. The regular channel that we entered is right over there. The flows right over there. Um, roadway width, so on and so forth. So essentially, the input data is in text format and the model runs and reads the text format right over here. Okay, so that was the existing condition. In the second part of the video, we are going to talk about the proposed condition. All right, in order to model the proposed condition, I'm going to right click on the existing condition over here and create a duplicate of that. Once I create a duplicate, and I can right click on it and rename that project folder instead of existing condition to proposed conditions. All right. If you click on the culvert again, it's going to take a while, a couple of seconds, and run it. And the culvert analysis folder will be open for you so you can modify it and enter the data related to the proposed condition. While this is thinking and running the model, what we can do is um, add different parameters on this window. But we want to be mindful of a couple of things. We want to start from smaller diameters pipes and smaller pipes because the cost is important when you are designing a culvert as well. Okay, so I'm gonna, for the educational purposes, I'm gonna start changing some of the items and parameters on this window, and then step by step go ahead and see what would be the impact of changing these on the headwater and the water inside the barrel of your culvert. So right now, as you can see, the headwater is about 1026 and the culvert is running full. And I showed you that the existing condition is an outlet control culvert. Okay, and the outlet control means that um, a wide variety of factors will impact the flow in the culvert, including the roughness, the diameter, the slope, tailwater, so on and so forth. Okay, so the first thing that I want to try, I'm going to try and increase the um, diameter. But instead of increasing the diameter, the first thing that I want to do, I want to add another barrel. So if you change this number to 2, you're going to have 2 pipes that have exactly same characteristics. And those exact characteristics are the inverts, the diameter, everything is the same. Okay, so I'm going to have this and run it. Oops, there we go. And run it and notice how if the headwater changes at all. So I'm going to click OK and see if the headwater is going to change anything from 1026. All right, as you can see, the headwater came down a little bit, but it didn't change that much. This is telling me that um, in addition to having another barrel, what I want to try is increasing the pipe diameter as well. Okay, so again, double clicking on the culvert. So now I want to have two barrels of two pipes that instead of having the diameter of 2.5, they are going to have the diameter of, I'm going to start with 3.5. Okay, um, and then I want to change the slope as well. So instead of, right now the slope is very actually flat, so it's 0.1%. So what I'm going to do, I'm going to change the inlet elevation from 1019.69 to 1020.1. And when I do that, you can see that the slope is going to be updated from 0.1% to 0.3%. Okay. And with these two changes, which are changes in diameter and the slope, I'm going to click OK. And again, now we are going to monitor and see if the headwater is going to change again. All right, so the headwater changed again. Now you can see that the pipe is not completely full. You can see the profile of the water surface elevation over here. Let's right click on it and go to Analyze Crossing and take a look at the summary table. Now the culvert is not outlet control anymore, it's inlet control. Okay, so that means that the inlet characteristics are significant when it comes to determining the headwater characteristics. Okay, now one of the things that I have explained in the GitHub page that I put in the description section is the concept of floodplain culverts. The floodplain culverts are usually smaller and they're placed a little bit higher, usually in the floodplain to make sure that they capture the water that goes in the floodplain. So what I'm going to do, I am going to go to the culvert crossing data, and right over here, I'm going to duplicate the culvert over here. I'm going to click on this duplicate, and another set of culverts will be added over here. And I'm going to call these set of culverts floodplain culverts. Okay, so now we got floodplain culverts that we need to define, and we have the original set of data. Okay, now for the floodplain culverts, I'm going to have two floodplain culverts. And let's say that I'm going to start with the size of, I'm going to start with 1.5 diameter. Again, we have two barrels. Um, the other thing that I want to do is probably a good idea to change the, um, it would be a good idea to change the elevation data. So the slope is a little bit steeper. So what I'm going to do instead of 1020.1, which was the inlet elevation of the original culverts, for the floodplain culverts, I'm going to make the slope a little bit steeper by raising the invert of floodplain culverts. And I'm going to put it to 1021.6. Okay. And then if I click on the slope, you can see that now the slope is a little bit more than 1%. Okay. So right now the depth is right over here, which is a little bit higher than 1025.5. If I click OK and wait for a couple of seconds, it will give me the results and I can see if the headwater is finally going below the road or not. It went down a little bit. Now it's less than 1025.5, but still overtopping. Okay. Um, Again, the profile is very similar to what it was before. This is, again, probably inlet control. This is for the original culverts. Now you can click on the floodplain culverts to see how that looks like. It looks like we do have enough cover. You can clearly see that this is steeper than our original culverts right over here. Okay. Um, I think to make sure that the culverts are, the roadway is not going to be flooded, I am going to culvert crossing data. And instead of having 3.5 feet pipes, diameter pipes, I'm going to change that to 4 feet, 48 inches, and see if that does the job. If not, I'll go and increase the size, the diameter of the floodplain culverts as well. I can also play with the type of inlet configuration. Square edge has the case of EF 0.5, which means a little bit higher energy loss right at the inlet. So I can maybe change that to something like the groove end in head wall, which has a case of EF 0.2. This is also going to be important essentially specifically because right now our culvert is um, inlet control. So I'm going to change it for our main culvert and also change it for my floodplain culverts as well. And for the main culverts, I already increased the diameter to 4. So let's click OK and see if the headwater is going to go lower than the top of the road. So the road is not flooded for our design discharge. All right. As you can see, the headwater is lower. It's let's see if it's flooded or not. I'm going to right click on this and click on Analyze Crossing. And for it looks like that the total discharge over the roadway is 0 when yeah, for this number. But I think our discharge, the design discharge was 243.76, was 243, yeah, 0.76. So we are very, very close. We're very, very close. There is still a little bit of discharge over the road, but I think we can change that pretty easily. How do we do that? Okay, so I'm gonna close this. Go to this time. I'm gonna edit the floodplain culvert. So let's edit that data. You can we can increase both of these to 2 feet. Or maybe you can play with, instead of having a concrete pipes, if your site allows, you can use PVC or smoother pipes to see how it works. Or you can change with the slope. It looks like we do have some cover over here, so we can maybe make the slope a little bit steeper. Um, but I'm going to keep 2 barrels of culvert and keep the diameter exactly the same. This will, for sure, is going to bring the level of water below um, the top of the road, and click OK. After a couple of seconds, we are going to see that finally our headwater is below the top of the road. There we go. Okay. And for the culvert also, you can see that as well. Okay. So now this is essentially the design that we came up with. We just back and forth, trial and error, change some parameters. We wanted to see how it's going to impact the flow in our culvert. Now you can see in our big 4 feet diameter culverts, the culvert is not, the barrels are not full for our design flow, and it's running partially full right over here. Okay. The last thing that you will check when you are looking at the culvert data, and I'm gonna actually go to the analyze crossing. One thing that is important to take a look at is your culvert summary, and take a look at the outlet velocity. The outlet velocity will help you to understand if you need to have riprap at the outlet to prevent erosion from happening. One last thing that I would like to mention over here is the culvert performance curve. So when you are under culvert summary table, when you click on the culvert performance curve, it gives you the relationship between headwater elevation and the total discharge for both inlet control and the outlet control. This is an important characteristics of the culvert as well. All right, so this was a short introduction to HY-8 and culvert hydraulic design. I hope that this video was useful for you. Again, if you take a look at the description section of this video, you will find a link to a GitHub page that have some resources for you if you want to learn more about different hydraulic design aspects of culvert design.